Hi. Do you think it is extremely difficult or a Herculean task to score 100 upon 100 in CBSE Class 12 Chemistry Board examination? Not at all. If you check with the toppers, they will tell you how they get their score. It is through continuous practice and hard work. They practice as many previous year's questions as they can. They practice all the NCERT textbook questions like index questions, solved examples, exercise questions, etc. with perfection. So, if you want to score like the toppers, you have to practice like the toppers do, right? Quite natural. Hi, I'm Prasanna and welcome to my platform. Today, we are going to do few more PYQs from chapter solutions. Let's see what these questions are. Question number 1 is assertion reason question. Assertion is a raw mango placed in a saline solution loses water and shrivel into pickle. Reason, through the process of reverse osmosis, raw mango shrivel into pickle. You know, a raw mango contains a lot of water content inside. And when it is placed in saline water, outside in saline water, the amount of water is less. So there is flow of water from inside of the mango outward. That means there is osmosis happening from inside of the mango to the outer saline solution through the cell membrane. So what happens here? The mango will shrivel. So assertion is correct. Reason, it is written reverse osmosis. No, reverse osmosis is not correct. It is osmosis which makes the mango shrivel. Clear? So the correct answer is option C, where assertion is true and reason is false. Okay, great. Next question is a numerical type of question connected to one cofactor, though it is MCQ. The question is, out of the following 1 molar aqueous solutions, which one will show the largest freezing point depression? You know, freezing point depression is delta TF. And you have to find out which one will have the highest delta TF. Now, they all have the same concentration and they all are aqueous solution, same solvent. So, KF and M will be same in the formula for all of them. Let's see how to calculate delta TF in this case. You know, delta TF is equal to I into KF into M. As I mentioned, KF and M will be same for all these solutions. And basically, it will depend only on the value of I. So if you come to NaCl, NaCl will dissociate to form Na plus and Cl minus. Number of particles after dissociation is 2. And you know, if it is complete dissociation, assuming complete dissociation, if not mentioned, you can assume complete dissociation. And then alpha is 100%, okay, 100% dissociation. So alpha will be 100 by 100 and I will be same as N. So that will be 1 plus 1, 2. That is total 2 particles coming after dissociation. So I will be 2 for NaCl. What about sodium sulfate? Sodium sulfate will dissociate to form 2 Na plus and SO4 2 minus. It is Na2SO4. So we are getting 2 plus 1, 3 particles after dissociation. So I will be 3 for sodium sulfate. Now next one is glucose, which is a normal solute, no dissociation, no association. So it behaves normally, I value is 1. What about aluminum sulfate? Aluminum sulfate will dissociate to form 2Al3 plus and 3SO4 2 minus. You can see 2 plus 3, 5 particles are produced after dissociation. N is 5 and I will be 5. Now let's compare the Van Hoff factor values for these compounds. NaCl it is 2, Na2SO4 it is 3, glucose it is 1 and aluminum sulfate it is 5. Delta TF depends only on I here because these two are same for all of them. So highest I value is for aluminum sulfate. So highest delta TF will be for aluminum sulfate. make sure to practice such Van Hoff factor related questions, because we see that many students lose mark when such questions are asked in the paper. Make sure to practice. It is a must, right? Okay. Now, the next question. It is also a numerical connected to osmotic pressure. The question is, for a 5% solution of urea, molar mass 60 grams per mole, calculate the osmotic pressure at 300 Kelvin. You are given the R value. And what is the osmotic pressure formula? Osmotic pressure formula is pi is equal to I into CRT. It is better to include I in the formula. If it is normal solute, you can take it as one and neglect. Otherwise, you will have to take that I into consideration, right? So if you don't practice by taking I, you might not write I where it is required also. Okay? So better to include I and get the formula. Now, I is 1 here for urea because urea is the normal solute. So that's 1. Then C is the molarity. That is mass of solute by molar mass of solute into 1000 by volume of the solution in milliliter. Instead of milliliter, you can take liter, then it will be 1 by. Okay. Either way, it is okay. Into RT. But do you know this mass of solute and volume of the solution here? Not directly given, but indirectly it is there in the data. It is written 5% solution of urea. Normally in osmotic pressure, such questions, when they write the percentage, normally it means W by V, unless mentioned. Okay. So 5% W by V means it is 5 grams solute present in 100 ml solution. So urea 5 gram present in 100 ml solution. So mass of solute is 5. Molar mass is given as 60 into 1000 divided by volume of the solution is 100 into R is given as 0.0821 and temperature is 300 Kelvin. Temperature has to be in Kelvin in this osmotic pressure calculations. So when you solve this, you are getting 20.525 as the numerical value. And what will be the unit of this osmotic pressure here? R is expressed in ATM. So the unit of osmotic pressure here will be ATM. So this is the answer for this question. Make sure to practice such questions if you want perfection. Clear? Now the next question is another numerical question, but simple. It is MCQ, but some students lost mark in this year for this question. Let's see. 50 ml of an aqueous solution of glucose, molar mass 180 grams per mole, contains 6.02 into 10 raised to 22 molecules. The concentration of the solution will be. Here the concentration unit used is capital M, molarity. So we have to calculate molarity of the solution. And how to calculate molarity? You know, molarity is number of moles of the solute divided by volume of the solution in liter. This is the definition of molarity, right? Number of moles of the solute present in 1 liter of the solution. But how to get the number of moles? To calculate the number of moles, there are multiple ways. The simplest is mass in grams by molar mass. Molar mass is given here, but mass in gram is not given. So let us not go for it. There is another formula to calculate number of moles. Number of particles divided by Avogadro number. Number of molecules given to you. So that's the number of particles. That divided by Avogadro number, you can get number of moles. So in the place of number of moles, you can write number of particles divided by Avogadro number. So this is the number of moles. Number of particles, 10 raised 22. Divided by volume of the solution. Volume of the solution is mentioned 50 ml, but that should be converted into liter. So 50 into 10 raised to minus 3. Or you can bring this minus 3 up as 1000 and you can use this in milliliter. So when you solve this, you are getting 2. So the answer is 2 molar. So make sure to apply properly in the areas mentioned. Clear? That's about this MCQ question practice. Now, next question. It is a theoretical question. What happens when a pressure greater than osmotic pressure is applied on the solution? You know, when you apply a pressure more than osmotic pressure, reverse osmosis will happen. That is, the solvent will pass from pure out of the solution to pure solvent side. Reverse osmosis means solvent passes from the solution to pure solvent side. So reverse osmosis happens. Then acetone is added to pure ethanol. You know the combination of acetone and ethanol, it is an extremely important example under positive deviation. We have discussed the same in one of the PYQ sessions before. So, you know in ethanol, molecules are hydrogen bonded. When you add acetone into it, acetone molecules will enter in between the ethanol molecules and weaken the hydrogen bonds. What will happen then? Escaping tendency of the molecules increases. So it will lead to increase in vapor pressure and leads to positive deviation from Raoult's law. So make sure to practice all these deviation questions from the textbook, and it is a must. I hope all these questions and their answers, what we discussed today, are crystal clear to you. And continue watching, wait for more sessions. And after these few more sessions from solutions, we'll be going to the next chapter. Make sure to like, share, and subscribe to my channel. And please do comment if you have suggestions, if any. Okay? Feel free to do that. So, see you in for the next session. Bye.